Hey y'all, I thought I'd make a video for debugging with a few common issues that I've come across. And I say common because I make them routinely, but I've discovered on how to debug them quickly so they don't come a problem on my C++ program. And I have two windows open up here. I have the Linux lab through PuTTy, and then I also have Visual Studio on my right hand side. PuTTy is a remote desktop application, whereas Microsoft Visual Studio will run off of my own computer. And so Visual Studio can be a performance hit if your computer's not that great. But I'm going to go over both ways that you can debug in both of them. I've written up some code. The code I have in both are the exact same. So let's go ahead and actually go over it over on the Visual Studio side. It's easier to read and scroll through. So I have a class called data, a class called bug. The names just came up with them. Each one has different stuff inside them. And then I declared the functions up at the top, and these functions I define down here. So my main, it has a multi-dimensional array, because there's usually some problems you can run into multi-dimensional arrays. And then down here I have some vectors, and these vectors will be what I'm going to use to help enforce what the issue is that I'm going to show you how to debug. And one vector is going to have the class data pointers, and one vector is going to have the class bug pointers in it. There's going to be 5 pointers in each vector. And then there's going to be an integer input. That input is going to go through a switch case, which is going to go through the 3 different bugs that we're going to look at. This program is set up to fail. I'm going to let you know that right now. So there's my creation. It's just create a pointer and then return the pointer. So the first bug that I'm going to go over is this one. I call it vector it, because it's basically going to be an iterator that goes through 2 different vectors. This current function has no purpose other than to just delete what's contained in the vectors, and that's its only purpose. Usually when I write code to make things easier, if I'm going to write the exact same thing over and over and over, I'm just going to copy and paste and then change the variable names. However, where this can become a problem is, you see in this code, this variable is called example it. The nice thing about Visual Studio is if I click on example it will highlight everything with example it, so it makes it easier to change. So as you see down here, you already see the flaw. Example it is down here in this loop as well, and that's going to cause a fault, because now it's pushing vector's pointer into memory that it shouldn't be going, and a memory that shouldn't be existent as well, since we just deleted and cleared all of vector's memory. Over here it's the exact same, however I can't click and highlight it, so we don't have that nice feature, but there's the code right there. Since it is through remote desktop PuTTy, which doesn't have mouse control, it's all through arrow keys and whatnot, navigation, page up and page down. And then, so that's the first one, and that's going to be under switch case 1. And then the second one I'm going to do is a pointer null. So we're going to try to access a null pointer. So this is going to be 2 bads, basically. The first bad is it's going to delete something that's inside a vector, and without using the vector's delete or the vector's erase. I mean, you could technically do that, but you'd want to erase it through your vector before you even moved on with your program. And then it's going to point it to null and then try to display it. You could also run into problems if you delete it and then don't point it to null and try to display it. It may or may not display what's in that memory. You technically shouldn't have access to that memory because you have reallocated it, I guess you could say. You released it back to the operating system. And when you do that, that causes issues with the operating system wanting control of that memory, and you chose to keep control when you shouldn't have, because you deleted it right there. And then the second one I'm going to run it, the third one is multi-dimensional arrays. So I've run into segmentation faults with this, because you'll see here that row, And again, when you do it through Visual Studio, it's easy because it highlights it. If you copy and paste your for loop, say it's a really big dimensional array and you're just copying and pasting stuff just to make it easy, or if you're just doing it off of sight, like, okay, I need to copy that loop, but instead of using row, I use column. And then the last one, you just go into autopilot and you just type in row because that's what you see. And as a result, it's iterating row instead of column, and your program's going to crash. It's going to crash with segmentation fault for these two. And then this one is just going to be an endless loop. And I'm going to show you that, at least through PuTTy. Through Visual Studio, things happen differently because it's Visual Studio and it's cooler. So let's go ahead and run this program in PuTTy. So clear my screen. As you can see, I was testing it out. So let's go ahead and see here. I already have it compiled, I believe, but we'll just to make sure that it's compiled, we'll go ahead and compile it again. So now that it's been compiled, we're gonna just run it. So run program. So far, so good. It compiled perfectly. The compiler didn't find any problems. And sometimes that's going to happen. You're going to be like, there's something wrong in your code, but it's saying that it compiles fine. So then you go to do one, which is option one. And here we see no reaction. Nothing's happening. It's just stuck. With PuTTy, it kind of throws it into an infinite loop. And where it's getting this infinite loop, in my opinion, is right there on that example iterator. It's either going in an infinite loop or it's going to do exactly what Visual Studio does, and PuTTy just doesn't know how to handle that. So let's go ahead and leave that, and let's try it again with 2. So instant crash, segmentation fault. Let's try it again with 3. 3, so 2 was the null pointer. It just says you can't display a null. It just segmentation faults. There's no memory to display. Something's going wrong with your memory. The third one, multi-dimensional array, you got this row that's increasing over and over and over that shouldn't be increasing. And as a result, column never increases, just row does. So it gives you a long list of just random numbers until finally it says, oh, this is a memory fault. It was displaying memory that it shouldn't have been displaying is what was going on. And so let's go ahead and go back into that program, and I will show you what you can do in PuTTy to help with that debugging. So as you can see, it didn't show us what was wrong. If all this code was in one function, we would have no idea which function would have failed. It just instantly crashed. So with the iterator, the best thing I can say to do for that is just to double check every time, if you're going to copy and paste, that you've got all the variables correct. For the pointer, anytime you put a pointer to null, or if you don't have a pointer to null, like after you delete it, you should add an assert. So as you can see, I included asserts. So you should add an assert right here. So yeah, you're going to want to add some asserts that basically say, hey, is this expression true? And if the expression is not true, then it should cancel the program. And with it, you have this assert that I just put in there that says example is equivalent. So as long as example is pointing to null, this assert won't trigger. And then you have an assert down here that you can put that if you're going to put it before a statement where you're going to dereference a pointer, you should say example2 does not equal null. This is not for programs that you're going to release. I mean, you can still put an assert in a program that you're going to release, but the assert is not for the user. The assert is for you to find the problem. So you should use, paranoia. Anytime that you're going to reference a pointer, make sure it's not pointing to null. And then anytime you delete it, make sure it is null. You should address it to null, and then after you address it to null, make sure that it did go to null. The assert doesn't do anything wrong to the code. It just makes sure that, hey, this variable is doing what you want in that situation. And to include asserts, like I said, you got to include the cassor library right up there. And so this is how we're going to the the uh, pointer null function. Let me confirm it, that's number 2. So pointer null is number 2. So we have this assert here. If it does not equal null, then it should run the count quoit, which is console output. All right, let's see here. So we do a.out, and then it's in caps, my bad. A.out, and then 2. Segmentation. Sorry about the pause. It wasn't working and I flipped out. The reason why it wasn't working is because I forgot to compile it. Wow, common mistake. Anyways, so we go to a.out it and we ask for the number, and it says, just like you see on the function above, assertion called, and it's on line 139. We can see it right there. I right clicked. When you right click on PuTTy, it copies and pastes basically. If we go to Emacs, or we go back to edit our code, we can go down to 139, and it will basically tell us the exact line that failed. And the exact line that failed is right here. All right, so we deleted it and it wasn't pointing to null. And so that was if it's not pointing to null. We can go ahead and delete that because we now know it. We know that it's pointing to null because we put that there. However, you should put an assert here after it to make sure that it did point it to null. Just call it paranoia. And when you write your code, if you get used to this, you'll never have that segmentation fault due to that. All right, so now if we save it and leave, it shouldn't give us the error for that null, but it should give us the error for the other one. So let's go ahead and compile it this time before we run it. And so we're going to run 2 again, and again another flash, and this time it was the assertion right below that 142. And so we go to line 142, and line 142 is the assert, hey, your pointer is pointing to null, and that's why it crashed. So that's how we can address that pointer. And so now the multi-dimensional array, that kind of falls under how you can fix this one. Double check your loop variables and make sure that it doesn't crash with the loop variables. So now I'm going to show you how to debug though in a better form, how to debug in a better way through Visual Studio. And you saw my textbook up. Yeah, I'm still in college, obviously. So here we go. So over here, I pulled up the asserts because I thought I was doing it wrong. No, it was when I forgot to compile it. And so I was like, what am I doing wrong? I know I did this right. It was because I forgot to compile it. And so over here, if I run this now in Visual Studio, and we haven't changed any code over here in Visual Studio, we'll go ahead and close PuTTy since it's not needed. So give me a moment. Let's close that first. So PuTTy's closed, and so now we have Visual Studio open, and here's our command box. So if we go ahead and choose option 1, so this is the iterator one, and remember in PuTTy, all it did was go into either an infinite loop or the program wasn't telling us what was wrong. So if I do option 1, in Visual Studio, it automatically tells me, hey, there's a debug assertion that is flipping here. And PuTTy wasn't telling me about that assert. So what assert is it flipping? Well, if I go to retry, it will tell me. It'll go right to it. And so it's going to throw up this. This is the exception that was thrown. This exception is inside the vector class, and it has to do with the iterator. You don't have to know much. I mean, not a lot of people will understand what that says, but you see iterator and you know, okay, this has something to do with my iterator. Well, if I go back to my actual code and I click continue, it's going to point it out. It's going to say, hey, you didn't fix what I just said is wrong. This is what's wrong, is this iterator right here. So that needs to be changed to bad news. And that's what made my program crash. I couldn't find it, and it pointed it right out to me. That was one way it debugged it. And you do have to run it in the debug solution and run the debugger or run your program through Visual Studio up here with the play button. Forgot to mention that. So it debugged it. We debugged it. It probably won't continue. I've tried this before. It usually doesn't continue. It's stuck in that loop of the exception. So we'll have to cancel. So we'll have to stop the run and then run it again and see if it now gives us a problem, which it shouldn't. It ran the program and it exited just fine because all we did was do switch case 1 and then it returned. So we just debugged vector it, and we used Visual Studio. It pointed it right out to us. Very simple. All right, so now we're going to do pointer null through Visual Studio. This one doesn't have an assert on it. So let's go ahead and do pointer null and see what it says. So immediately it gets stuck. And not only is it stuck, it now says there's something wrong. So it's again going through the debugger and it's saying something's wrong here. This is where we're wrong. Return data. And why it can't return it is because if we remember, that pointer was set to null. So now it's trying to access a pointer that is a data pointer, but there is no data to return. It's a null pointer. And that's where it's crashing as memory is not present and it failed. And so now you can say, okay, well, it crashed here. Well, what was returning data? And you just go to that function that was called. And in Visual Studio, a easy way to find what all the references to a function is right here. So I can just say, okay, here's all the points where I call that function. So I know it's related to what it's returning. Well, let's go find out where it was called. It was called right here, and there's the problem. And in a nice way, another nice thing about Visual Studio is it has what's called breakpoints. And so let's go ahead and close this program, cancel it because it's broke. So stop running. We broke it. and this is running on my own computer, so you know that could break actual memory and cause a blue screen of death if you do this inappropriately. But here's what we call a breakpoint. So here's a breakpoint. If I click here on this left side, I can just insert what's called a breakpoint. Or I can do it in my main code as well. So we'll add 2 breakpoints. We'll put a breakpoint right here as well. So actually, no, I want to put it right here to kind of give you an idea of what breakpoint does. So I'm going to say insert breakpoint, and that puts it just right over there. So when I go to run my code, it's going to go right to that breakpoint and stop running. When it gets to that breakpoint, I have these things down here that I can use to help debug. So there's this watch, and watch has variables I can enter. So a variable I could enter would be my vector. I want to know about my vector. It's going to tell me the size of my vector. If I want to know a specific part of my vector, then I could do a specific part. That array index is out of bounds. So that vector doesn't exist yet because it wasn't created yet. Even though that vector is in bounds in this program, it's not gotten to that part of my code yet because it stopped right here. It stops execution. That's what a breakpoint does. I'm sorry I didn't explain that. A breakpoint stops execution, and you can do it one line at a time now. So I want to initialize that line, and it tells me how long that line took to initialize. I want to initialize the next line. So where the yellow arrow is, it has not done yet. The line previous, it has. So I want to initialize that line. All right, and so now it's going to go through this loop. And then if we look at my vector 1 now, it does say it's in bounds. And now if I put a my vector 4, not 5, 4 in there, we'll see if it's on 4 yet. I don't know if it is. It's still out of bounds because it hasn't initialized 4 yet. So if we go again and again, it initialized it. And once it initialized it, it tells you what's in it. It doesn't just tell you like, hey, this vector is size. It tells you what's actually inside that vector. It's an A, letter A, and a data 1. And it tells you the exact memory location that it's located in. So then if I want to just continue on and say, okay, I'm done with this breakpoint, let's go to the next breakpoint. So I just click continue. So then it takes me back to my program up on my console, and it says enter number. So that's the next thing that it says, because our next breakpoint we haven't hit yet. So I believe we put that breakpoint in the null pointer. So let's go ahead and do 2, the null pointer. So my program hasn't crashed yet. It entered the function. If we were doing this through a normal function, it would immediately crash as segmentation fault, memory issues. So it took 20 milliseconds to get to example 2. However, that was probably me talking to you, included 20,000 milliseconds. But so we have our arrow right here. That means it hasn't deleted yet. So if I look at example 2, and we can go ahead and pull that up, local example 2, it still has an address. It tells me the address. As soon as I push next, it's going to say, okay, we deleted it. It's kind of an address, but not really. It's not pointed to null yet, and now we're going to point it to null. And so now it's pointed to nothing. And then this code runs. So right here, this code hasn't run yet. As soon as I run this is where it's going to crash. And I don't want to run it because I already know it's going to crash. So I'm just going to click stop. I wanted to show you guys that kind of helps you see what example 2 is. So if I put a statement here, hi, we're just going to say hi. If I put that in PuTTy, just because it's trying to show example 2, I won't see that hi. And that's where debugging comes hard in PuTTy, is I won't see that hi at all. But if I run it through Microsoft Visual Studio, and it goes to this debug, and I say continue, and then I do 2, and it goes back to the breakpoint, and I click next, and then it does the hi. If I go to the console, it put hi there. So it will display it in Visual Studio with the breakpoint of hi. So I know my code hasn't broke yet, and then I push the next iterator with the step over. That's up here, by the way, guys. It's up right up here, step over or F10. And then it crashes, and that's where it says, no, we can't perform this. And you immediately know that's the part of your program that's falling apart. Besides the fact that Visual Studio is kind of telling you where it's falling apart. So let's go ahead and skip out on this one because we did that. Next, we're going to debug the for loop. So I'm going to go to this. I'm going to put a breakpoint there, and we're going to skip over this breakpoint now that I showed you guys that, and we're going to go to 3. So 3. Here we are in this loop, and we're going to go one step at a time. Local variables is cool numbers, and if I click next, row will enter right here. You can see that it's uninitialized because it has not set it to 0 yet. All it does know is that row exists. So as soon as I iterate, it knows row has a value, and it tells me the value, and it tells me the location of row if I were to open up the memory panel. There is a memory section that allows you to see what is in all of the memory as well in Visual Studio. It shows all the hexadecimal addresses and everything. So then we iterate, and we know column has no value yet, so we're just going to iterate again, and column is 0. Because this is still the first run through the loop, everything is 0. So we have that, we have that, we have that, we have that, and on my console output, we can see the numbers that are going to display, but we can also see that row is the only thing that's increasing and column's not. There's a problem. Column should be going up every time this goes up. And then here's where the problem comes. When I iterate this, I get 5, 1, 2, 3, 4, which is what's in the row and column address that's currently linked. But if I push play again, I will get a segmentation fault. And the reason why is we can see here that 6 shouldn't exist for row, and it does. So what's going on here? So if I keep going, something's wrong with my console output. But we can see with these debug numbers right here what it is. Row's not supposed to be 13, and if we kept this going, eventually it would crash because it's going to know memory is being accessed that shouldn't be being accessed. So right now it's displaying memory that we're not supposed to see. I thought I'd share that with you guys, some common mistakes that I've made, and also a way to debug them with the breakpoints and the asserts, and with kind of, if you do a copy and paste, making sure that the variables are right. If you hit the autopilot and you just start copying the wrong variable, making sure that's right. Y'all have a wonderful evening, and talk to y'all later. Bye.